Hey TSConf, I'm Dan, and I'm going to be speaking to you today about TypeScript types, the first 500 years. You might remember me from previous TSConf when we were all in person. I spoke about testing types, or from my book, Effective TypeScript. So I want to talk today about what types are. So they're clearly important in TypeScript. It's right in the name, it's in the marketing material, but we have a lot of experience working with types, and we kind of know some of their properties, but if you had to define a type, how would you do it? A definition of the word type. It's actually pretty hard. So while you're thinking about that, I want to go back to the beginnings of TypeScript, like way back to the beginnings. But with this guy, Michelangelo, who's a Italian sculptor and painter. So he lived near the marble quarries of Carrara. I think this is a slightly later photo. And back at the start of the 1500s, they had this big unfinished block of marble, and no one was quite sure what to do with it. If I'm not mistaken, I think it had a name. Yeah, unknown. So Michelangelo, he knew what to do with it. He had this great quote that every block of stone has a statue inside of it, and it is the task of the sculptor to discover it. So he looked at that block of marble, and he saw the statue he wanted to carve, and he carved the David. And my Italian is not so great, so I'm not exactly sure what David means. I've heard a few possible translations, like my API or DB schema. I've even heard HTML element. So we'll get into that. So let's start carving up this marble block with Michelangelo. So the first cut we're going to make is a small but very important one. So we're going to cut off undefined and null. And once we do that, the block of marble changes names a little bit, but we don't need to get too deep into that. The next cut we can make, if we're very careful, if we make a very precise cut, we can cut off string, boolean, symbol, number, and big int. These are the primitive types in JavaScript, and what we're left with is a marble block that has it's named object with a lowercase o, and if Michelangelo is okay with it, I think we're going to switch to a more schematic representation of these now. But when we start to do this, these are starting to look a little bit like sets. So now we're ready to present a definition of a type. So here's one. This is from Boris Cherny's Programming TypeScript. So he says that a type is a set of values and the things you can do with them. So in this talk, we're going to focus on the set of values. The things you can do with them part has to do with access modifiers, things like private and read-only. So sets are a very mathematical idea. So how would some mathematicians like these guys here define a set? So there's three main ways that you can define a set, and all three of these ways have pretty strong analogs in TypeScript. So first of all, you can define a set constructively just by listing the members of the set. So for example, red, green, blue, that's a set. ABC, that's a set. 1, 2, 3, that's a set. Another way that you can define a set is through a membership test. So this is a way of telling whether a value is in a set or not in a set, which, if you think about it, is really what the definition of a set is. Either you're in the set or you're not in the set. So an example of this is the set of real numbers x, y, such that x squared plus y squared is less than 1, which, if you remember your algebra or geometry class from high school, you might remember is a circle. And another way you can define a set is in terms of another set. So example of these would be the union of numbers and letters. That defines a set in terms of two other sets. You can take a product. So Z is how mathematicians that's how they talk about all the integers, the set of integers. So Z times Z would be all the pairs of integers. You can also subtract sets from each other. So R is the set of real numbers. So you could talk about kind of crazy sets like the real numbers that are not integers, R minus Z. So those are the main ways to define a set. So now let's go back to that big undifferentiated block we had earlier, object, and let's kind of explore how we can think about that as a set. So remember, types are sets of values. So each little dot I draw in this set represents a value. So here's one. It's an object literal, name tsconf, year 2021. It's an object, so it belongs in this set. Regular expressions in JavaScript are objects, and so all the regular expressions belong inside this set. So ABC, DEF. Arrays in JavaScript are objects, and so all the arrays belong in here too. So we have the empty array and a 3-element array here. And functions in JavaScript, also objects, so all the functions go in here. And if you're working in a web browser, HTML elements, also objects, and so all of the divs on your web page are also part of this set. So it's a pretty big set. Incidentally, in the early 1500s, there was this other guy, Leonardo. He was a little older. He was a painter and more of a JavaScript developer. He really didn't like Michelangelo. He thought Michelangelo painted like a sculptor. There were too many sharp lines, not enough shading or subtlety. Leonardo thrived on ambiguity. 500 years later, we're still not even exactly sure who the Mona Lisa was. And if you think his paintings are ambiguous, you should really see his API documentation. So let's look at user-defined types, and specifically interfaces. So here we've defined a conference interface that has names, a name that's a string, and a year that's a number. And here's an example value that's assignable to that type. So name tsconf, year 2021. So conference, whether you want to think of it this way or not, the conference type defines a set of values, and that set of values is a subset of the object type that we were just looking at. So let's dig into this a little bit more. So when you write the conference type, I think it's natural to think about, thinking of the 3 ways that we can define a set. It's natural to think that you're defining it constructively by saying how to produce the values. And so in this case, that interpretation would be that it's all the objects with, you form objects by giving them a name property and a year property of the given types. But I think it's actually better to think of it more subtractively, that you're defining a membership test. So let's look at what that test is. So values that are assignable to an interface are always objects, so you're part of that big object type. The second part of this test is, do you have a name property, and is it a string? And the third part of the membership test is, do you have a year property, and is it a number? That's it. That's the whole membership test. So let's look at how this plays out to some example values so that we can figure out whether they're assignable to conference. So tsconf, the string, well, it's not an object because in JavaScript strings are not objects, so that's not assignable to conference. This is the object literal we were looking at earlier, so it's an object, it has a name property, it's a string, it has a year property, and it's a number, so it is assignable to conference. How about this one? Well, it's an object, it has a name property, and it's a string, and it has a year property, but it's not a number, it's a string, so it's not assignable to conference. And then finally, this is the interesting one. So this adds a locale property to the second example. So is it an object? Yes. Does it have a name property that's a string? Yes. Does it have a year property that's a number? Yes. So this must be assignable to conference, which might come as a bit of a surprise. So this is not an object that you would get if you just created objects specifically with name and year properties, but in TypeScript it is still assignable to conference. It's allowed to have extra properties. So let's head over to the playground to see how this works exactly. So here's my conference interface and a value. So one thing that you might find interesting is if I just add the locale property to this object, I actually get an error. Was everything I said just a lie? Well, no. This is actually a separate process from type checking. So this is known as strict property checking, and it only happens for object literals. So this is sort of a strange quirk in TypeScript if you've never seen it before, but we can define a separate value O, and then we can just assign it to C, and now we've bypassed that check. So that's extra properties are not allowed if you're assigning an object literal to something with a known type, but that's a separate process from type checking. I think it's the best way to think about it is that it's a way to sort of catch things like typos that have to do with optional properties. So for example, I could add a isOnline Boolean property here, and if I typed isOnline true here, so technically speaking, this value is assignable to the conference interface, which I can see if I go back and use an intermediate object. But it's a little surprising, right? Because technically speaking, this assignment does work, right? It's an object, it has the right name and year properties, and isOnline is optional. So we don't have a isOnline property that isn't a Boolean, so this assignability has to work. But this is a mistake, and so the excess property checking is TypeScript's way of being helpful in situations like this, right? This is a great error. isOnline does not exist. Did you mean to write isOnline? Yep, I probably did. So I think of excess property checking as kind of like it's like a safety net to catch you to help you out of some of the strange quirks of assignability. But it's important to remember that it's not the same as assignability, and it doesn't change what that set that we defined actually is. If you want a way to define a set of objects that only have a specific set of properties, there's actually no way to do that in TypeScript right now. It's a very popular feature request, but it's it might happen someday, but not yet. So let's look at how thinking of types as sets and they're potentially having additional properties can actually affect the code that you write. So here we have a ABC interface. So we have three properties, A, B, and C, that are all strings. So let's write a function that works with this. So I'm going to write a for loop. So let's say we have K in ABC. And I'm going to look up the value. So, so this is a little weird. So what's going on here? So TypeScript is saying something about index signatures, but the root of the problem is that the type of K is string, which is a little surprising because if we're iterating over the keys of ABC, you might look at this definition and say, oh, well, that has to be A, B, or C. So, maybe you think that TypeScript is wrong about this, and you wanna just redeclare it with a different type. So we can use key of here. So now it's got to be A, B, or C, and now the lookup succeeds, and it's a string. So we could do fun stuff like out plus equals v dot. Let's do blank, and then we can return out. And this code type checks, and we can run it, and it logs ABC, so this works. But it actually, the blank tags are in there. I think the playground just strips them out. But does this actually work? So if you remember, we can add an additional property to this. So let's just add a date, and we get an error, but we know that this is excess property checking, right? So we can actually bypass this if we just put it in an object. And now the code type checks, but when we run it, we get this error that v.blink is not a function because dates don't have a blink method. And so TypeScript was actually right to complain at the start because k here might not actually be just A, B, or C. In this case, it could include D as well. And so in this case, v is not always a string. It actually could be anything. So we'll come back to this in a little bit. It's interesting to think about type inference in the context of thinking of types as sets of values. So when you write a statement like let x equals 10, every symbol in TypeScript needs to have a type. And so TypeScript has to figure out what the type of x should be. And so another way of thinking of that is that TypeScript needs to figure out what should the set of possible values for x be. And when you think about it that way, you realize that this is actually pretty hard for TypeScript. There's actually no right answers. It just kind of has to guess. And so depending on what type of assignments you want to allow, there might be different answers. So in this case, if you want to allow assigning 10 or 12 to x, then number seems like a good type. If you want to allow assigning 10 or the string 12 to x, then maybe number or string is the type that you're looking for. Or maybe if you want to be able to assign null, then number or null would be the best type. But without more information, TypeScript has to make a guess. And so in this case, it guesses number. The same thing applies to objects, right? So here we have this object that we've looked at before, and TypeScript needs to give it a type. So it needs to, in order to do that, it needs to decide what sorts of assignments it's going to allow. And so, and depending on the type it gets, some of these assignments will be allowed and some of these won't be. So if we provide this conference interface that we've been looking at before and we add a type annotation, that's telling TypeScript what you intend the type to be. And that makes it very clear what sorts of assignments should be allowed and what sorts of assignments should not be allowed. So in this case, only the first assignment is valid. But if you give it a different type, then different sets of the set of permissible values will be different, and so different assignments might be allowed, right? So if we say that year could be a number or a string, then the second assignment is valid. Or, for example, if we want to add an optional isOnline property, then the third assignment would be valid. But that's not the only way to make that assignment valid, right? For instance, you could add an index type, and in that case, the last assignment is valid, but sort of interestingly, the middle one is still not, because year has to be a number. So one way to think about type declarations is that they tell TypeScript what you intend the set of possible values for a symbol to be. We saw an example earlier where the types and reality got out of sync, and that led to an exception. So let's dig into that a little bit. So here we have a array with 3 elements, and we are grabbing off the first element of the array at index 0. So TypeScript is going to infer a number type for x. So on the right, we have the set number, and we have the value of x, which is 10. So then we can grab the next element. So the value there is 20, and it's still a number, so we're good. And then if we read the element at index 2, the third element, that's 30, still a number, so we're still good. But then for the next one, something interesting happens. We read the element at index 3, the fourth element, and there is no fourth element, so we get back undefined. And if we try to call toString on it, we'll get an exception. TypeScript will not flag a type error here. So the interesting thing here is that the declared type, or the inferred type here, number, and reality have diverged when we try to read past the end of an array. And so the term for that is unsoundness. So if the type the static type of the symbol and the runtime values always agree with each other, right? If the dots are always inside the set, then the type is sound. But in this case, we have an example of unsoundness, and so that's something that you need to watch out for in your TypeScript programs. There's been tons and tons of work in TypeScript that's been designed to fill soundness holes like these. So strict null checks is a great example, right? Before that, we couldn't distinguish null and undefined from values that weren't null and undefined. And then there's some newer work that's going on right now. So for example, the no unchecked index access flag will actually catch this error, or at least will make you do some more checking to make sure that your reads from the array are valid. So if you find this interesting and want to learn more, there's some more examples of unsoundness on my blog. So we talked earlier about the three ways that mathematicians like to define sets, and the third one was in terms of other sets. So let's look at what that looks like in TypeScript. So generally, the way you map between sets and between types in TypeScript is using either type operators or generics. So a type operator would be something like union or intersection. So here we have two types, ABC and BCD. And if you look at the Venn diagram of the values that are in these types, you can sort of make sense of what the union type and the intersection type should be. There's also operators like key of, so we can read off the key type of the interface. So here that would be A or B or C. We can index into a type, so we can look up the value types associated with particular properties. So the value type, or the types associated with the values of ABC are string or number. Or if we just want to look at the types associated with B and C, we could just do ABC of B union C, and the type comes back as number. The really powerful way to map between types, though, is with generics, and TypeScript gives us all kinds of abilities to do this, right? So here we've defined a make-for generic that takes type T, and it gives us back a for tuple with four elements of that type, which, back in the 1500s, Anders thought that generics were not worth the trouble, but Michelangelo really would have killed for this make-for technology. So we've talked about ways that you can break up the object type, but what about some of the other types in TypeScript? So for example, what about array? So since the beginning of time, we've been able to define arrays of particular types. So we could define an array of numbers, and that is a subset of array. Not all arrays are arrays of numbers. Since 2014, we've had tuple types. So tuples were fixed length arrays where you could define the type of the element at each slot. So for example, here we're defining a type that's a two-element array where the first element is a number and the second element is a string. So that let you define a different subset of array. Fast forward to 2018, and tuples got some new abilities. We got optional and rest arguments for tuples. So here we're defining a type that is an array with a number in the first slot, and then all the remaining elements are strings. So that's a new subset of array that we were able to define. And then last year, we flipped it around. So we gained the ability to put rest elements at the beginning of an array. So if you wanted to define a subset of array that was all the arrays with number elements followed by a string, you gain the ability to do that. Strings the same way. We've always been able to define variables with a string type, and you could assign any string to them. Then in 2016, we got string literals. So you could define types that were subsets of strings. So here, T could be either A, C, G, or T, and you can disallow certain assignments. And then in 2020, we got a pretty exciting new addition with TypeScript 4.1 with template literal types. So this let us define structured subsets of string. So here we have a color type that is the letters RGB, open parenthesis, followed by 3 numbers and a close parenthesis. So really the development of TypeScript has included a lot of new features that let you carve out narrower subsets or more precise subsets of larger types like object or array or string. And this is important because it helps you catch more types of errors. For example, Gary is giving a talk later about preventing 404s on your web page. So if you had a type that included all the valid URLs on your web page and none of the invalid URLs, maybe that would be useful. So let's wrap up with another quote that Michelangelo may or may not have actually said. The marble not yet carved can hold the form of every thought the greatest artist has. But we know that Michelangelo was actually talking about the unknown type. And the unknown type contains every type you've ever defined in TypeScript and every type you ever will define, including all your greatest TypeScript masterpieces. So go out there and find your types inside of unknown. I hope you enjoyed the talk. If you liked it, you might also enjoy my book, Effective TypeScript. It only covers the first 498 years of TypeScript, but I assure you there's still some good stuff in there. Thanks.